What is a rate problem? A rate problem is a problem involving some sort of rate like speed, earnings or work done. A rate is basically anything gained or lost over time. For example, you can gain speed over time. You can also gain money if you work hard and ace the SAT exam. Rate problems usually come in the form of word problems, and that is why students hate these questions, because you have to set up everything yourself. In this video, I'll show you how to easily solve these questions. Before I move on to examples, let's have a look at the rate formula. Rate is anything that is gained or lost over time, which means rate equals gain or loss over time. You can write it like this in the division form, or you can change it to multiplication form as well, which is rate into time equals gain or loss. I usually prefer this format. Now let's have a look at a couple of examples involving rate. Rate problems involving average speed are very typical and very important. The fundamental relationship in all motion problems is that rate into time equals distance. In this scenario, rate represents average speed. Most of the motion problems fall into three different categories. That is all you need to know. The first one is motion in the same direction that we call the catch-up problem. When I am in a class, I usually come up with a funny example. Let's say I am teaching in a classroom and there's this guy named Ali who happens to like my mobile phone. And when I am teaching, he steals my mobile phone and runs away from the academy. After a while, someone tells me that Ali has stolen your mobile phone. I run after him and at the end of the road, I catch him. That is the catch-up problem, where we travel the same distance, we started from the same point, but our rates might vary. The second category is motion in opposite direction. For the purpose of understanding, I'll keep the same example. Let's say Ali steals my mobile phone and now he has reached his house. Someone tells me that, sir, Ali is the person who has stolen your mobile phone. I call him up and I request him to return my phone, as I know he is the person who has stolen my phone. After some begging and some requests, he agrees to return the phone. Now he will start from his house and I will start from my academy. Somewhere in between we will meet each other. Now the thing that you need to understand is distance covered by me and the distance covered by Ali. You add those distances up and we will get the total distance from my academy to his house. The last scenario is the round trip problem. Again, I'll use the same strategy. Please forgive me, Ali. This time, Ali steals my mobile phone and he has reached his house. I call him up and I am extremely furious this time. I'm like, Ali, return my mobile phone or I'm going to call the police. He agrees to return my phone. I tell him to come back to the academy to return the phone. This is called a round trip problem. He was there at the academy, he stole my mobile phone, went to his house and then came back to the academy. In this scenario, he traveled equal distances in both the trips. Went to his house and then came back to the academy from the same route. This is something that you need to keep in mind. Now that we have looked at all these scenarios, let's have a look at a couple of examples. And I'll solve all these examples through one strategy. That's the best part. This is a very typical rate problem. That is why this is the first question that I will do with you. Let me read the question for you. If Brian can paint a fence in 4 hours and Scott can paint the same fence in 6 hours, when working together, how long will it take the two of them to paint the fence? I've seen this type of question so many times that I can't even tell you. Just the names and the variables change. Otherwise, everything else remains the same. Two machines are working together, two people are working together, two uncles are mowing the lawn, and similar questions. The formula for all these questions remain the same. The first part is to find out the combined rate. This is the first thing that you need to do. Calculate the combined rate, and in the second part, use proportion. That's it, and you will be done. So, what exactly is rate? Rate is basically rate equals 1 over time taken. This is something that you need to remember. 1 over time taken. Basically, time taken to complete one job. This is basically rate. So let's draw a table. We have Brian, these are our variables, and we have Scott. So what are their rates? Let's say this is, sorry for this line, I'm really bad with straight lines. So the rates are, Brian can paint a fence in 4 hours. So this is 1/4, and Scott can paint the same fence in 6 hours. So this is 1/6. The rate of Brian is 1/4 and the rate of Scott is 1/6. So what's the first thing you need to do? Calculate the combined rate. How do you do that? You simply add them up. 1/4 plus 1/6. You know, you take the LCM. You've got 6, you've got 4, 2, 3, 2. I know what the LCM is, but still I am doing this calculation for you. Okay, so the LCM is 2 into 3, 6, 6 into 2, 12. Let's calculate the combined rate. 12 divided by 4 is 3, 3 into 1 is 3, plus 12 divided by 6 is 2, 2 into 1 is 2. We have 5/12. Now this means that they can complete 5 jobs in 12 hours. Now you use proportion. We have got jobs and we have got hours. Very simple. If they can complete 5 jobs in 12 hours, how long will it take the two of them to paint the fence? How long? This is X, and they have to complete 1 job. There you go. In this, you will always have, proportion. This is our savior. I have talked about proportion at length in various chapters. You cross multiply. What do you get? 5x equals 12. X equals 12 by 5. This is your answer. Or you can say 2.4 hours.